Welcome back. In this video, we'll have a look at the second half of the second trigonometry assignment for Year 10 Math. Now going down, we have you are a specialist in flagpoles and shadows. A flagpole casts a shadow of 9.32 meters when the angle of elevation to the sun is 63 degrees. Find the height of the flagpole. So what we've got here is we have a flagpole, and there's a little flag on top. And what we're going to find is that the sun is going to cast a shadow that will go down like so. And the angle of elevation is 63 degrees. Now we know that the shadow itself is going to be 9.32 meters in length. And then the question asks, what is the height of the flagpole? In this case, we'll denote the height of the flagpole to be x. So what we've effectively got is a simple right angle trig problem that we solve. So using our angle of interest, we'll denote as theta. We're going to label all of the sides. So we have theta here, the unknown side, that is the opposite, and it's denoted as x. And then we've got the adjacent side that we're interested in, which is 9.32 meters. Hence, we can use the tangent ratio, so tan theta equals the opposite over the adjacent, and then we sub in the values. So tan 63 degrees is equal to x over 9.32. Rearranging to solve, we're going to get x is equal to 9.32 tan of 63. And thus, when we put these in our calculators, we get 9.32 tan of 63 comes out to be 18.29. So the flagpole is 18.29 meters tall. So the way in which we solve these word problems is we first decipher, or we try and decipher what's going on up here, and then we draw a mathematical diagram that we can use to solve the math. Now next question, you're a specialist in trains and mountains. You are on a train that is chugging up a mountain. For every 23 meters of track you travel, you ascend 7 meters in altitude. Calculate the inclination of the mountain. So you're on a train. It's going up a mountain. So up the mountain the train goes. And for every 23 meters of track you are traveling, you're going to ascend 7 meters. So every 23 meters you travel across here, you're going to ascend 7 meters. So what is the inclination of the mountain? So what is the value of theta in this case? So what we've got is a diagram we can use to analyze this problem. So using the angle theta, we're going to say the side length as 7 meters is going to be the opposite, and the side that's 23 meters, that's going to be our hypotenuse. So we're going sine theta equals the opposite over the hypotenuse. Therefore, plugging this in, sine theta is equal to 7 over 23. And then solving for theta, we get the inverse sine of 7 over 23, inverse sine. We put this in our calculator. (17.72 degrees). So the angle of inclination for the mountain is 17.72 degrees. So once again, the way in which we solve these problems is we first draw a diagram, and then we derive the mathematical model from the diagram itself. So the math itself isn't that hard, it's just deriving it. Now next part is you are a specialist in trees. You are standing at the base of a tree. You march 17 meters from the tree and then turn to face the tree. You look at the tip of the tree at an angle of elevation of 17.72 degrees. Compute the height of the tree. So what we're working with a tree, like so, and you're going to march 17 meters from the tree. Then you're going to look up at the tree, and the tip of the tree is going to be 17.72 degrees. So we're going to have a diagram roughly like this. Now what the question doesn't specify is the distance from here to here. So what we're going to do is we're going to change the diagram to cater for the information that we're given. So rather than that, we can go 17.72 degrees like so. Now we know that we're 10 meters away, 17 meters away. So therefore, we want to compute the height of the tree, in which case we'll denote it as y. So what we need to do is we need to label all the quantities we have. So we have theta, we have the adjacent, so this would be a right angle here, and then we have the opposite. So we're going to use the tangent ratio. So tan theta is equal to the opposite over the adjacent. Plugging in the values, we get tan of 17.72 degrees. The opposite is y, and the adjacent is 17. Rearranging to solve for y, we get 17 tan 17.72. And then we just throw this in the calculator to calculate the height of the tree. This will be 5.43 meters. And so the height of the tree is 5.43 meters. So once again, read the question, draw a diagram, and infer the solution from the diagram you're given. You'll find in most cases, you're not actually using that complicated mathematics at all. It's quite a trivial problem to solve. Final question. Your teacher may have hidden Easter eggs in the school. Starting from the flagpoles, you walk west 30 meters. From there, you turn 135 degrees and proceed to walk another 25 meters. Calculate your displacement from your starting position. So once again, I'm going to start off with a diagram, and we start at the flagpoles. Now what you're going to do is you're going to walk west. So we've got north, south, east, west. We go west by 30 meters. After that, you turn 135 degrees and proceed to walk another 30 meters. So it's a little bit ambiguous. You can either turn right 135 degrees or you can turn left 135 degrees. In either case, it won't matter because it's the final movement you make. So you're going to go, this one's a little bit tricky. We go about like that. So you're facing to the west still, and you turn 135 degrees, so you're turning like this. Or, alternatively, you're turning like this. The question does not state. However, what you find is that you walk 25 meters, regardless of which way you actually turn, left or right. And then throwing in the first annotation, you have 30 meters here. So then the question becomes, how far away are you from your starting position? So this red dot over here. What are these quantities? They should be equal to one another. We'll denote these as x. So what we've got is a schematic we can use to analyze this problem, so solving for x. Now looking at the quantity inside the triangle over here, we can calculate this by going 180 minus 135, and that should come out to be 45 degrees, like so. So in here we also get a 45 degrees. So what we're effectively going to be doing is looking at a condition where we know two side lengths, we don't know the one we're interested in, and we've got an angle that's complementary to the unknown side length. So the condition we're going to be using is the sine rule condition. So c squared equals a squared plus b squared. So Pythagoras' theorem minus the 2ab cos c. So we retrofit our labels to the triangle. So c, little a, little b. And then we sub in the values. So 25 squared plus 30 squared minus 2 times 25 times 30 cosine of 45 degrees. That will be our x squared. Now we pull up our calculators and we throw in our values that we have here. So 25 squared minus plus 30 squared minus 2 times 25 times 30 cosine of 45. This will come out to be 464.384. And the solution we have at the moment seems ridiculous because it's so large relative to the other side lengths. But we need to remember this is the square of our solution. So what we need to do is take the square root of our solution. And when we take the square root, what we'll find is our displacement, or the distance from our starting location. So shift, square root, shift, answer. That will be 21.55. So quite possibly the hardest of all the questions listed in this assignment. But to calculate it, all we need to do is we draw ourselves a diagram. We label it to the best of our abilities. So in this case, it's a little ambiguous. However, both solutions, even with the ambiguous case, still comes out with the same result. So draw your diagram, label all of the quantities, deduce the quantities that you need, if you need to do that, and then choose the appropriate rule to use. In this case, we use the cosine rule.